thing we're going to do is get comfortable with the angle menu on your calculator. So, right here above the apps button, it says angle. Everybody find it where it says angle? Okay, so I am going to have you type into your calculator 21 degrees and 18 minutes. Now, degrees, you know what a degree is, there's 360 of them in a revolution. They can be broken down into smaller pieces. Just like the hours on a clock can be broken into 60 minutes, the degree can be broken into 60 smaller pieces called minutes. So this is like 18/60ths of a degree. It's a fraction of a degree. To put that into my calculator, I would type 21, and then I go to my angle menu, so second angle, and right there's the degree mark, see it? Press enter, and now your calculator says 21 degrees. Now, press 18, go back into your angle menu, and you see right under the degree mark is the minute mark. Press enter, and then when you press enter, it converts that to what we call a decimal degree, 21.3 degrees. Okay, so now you try this one, 105 degrees and 13 minutes. See if you can get the decimal degree for that. What'd you come up with? 105.217. Everybody okay? Now, the calculator will go the other direction for you. So let's suppose you have a decimal, like 83.52 degrees. And you want to know how many degrees, minutes, and seconds that is. Well, we just type 83.52, and then go into your angle menu and click down to DMS, degrees, minutes, seconds. Press enter, enter again, and it says 83 degrees, 31 minutes, and 12 seconds. Again, just like on the clock, an hour on the clock is broken up into 60 minutes, which can be broken up into 60 seconds each. Same thing with degrees. So these are whole degrees. There are 60 minutes in a degree, and then there are 60 seconds in every minute. So this is really taken down very precise angle. Okay. All right, so let's try one more. 152.77 degrees. Find how many degrees, minutes, and seconds that is. What'd you come up with?
46 and 12.
152 degrees, 46 minutes, and 12 seconds. One tricky thing I should have told you before. If you go into your angle menu, you got the degree and you got the minute, right? But there's no second mark there. For whatever reason, if you want to type into your calculator 78 degrees, 11 minutes, and 15 seconds, if you want to type that in, we'll type 7, but do it with me, 78, you know how to get the degree mark. And then 11, you know how to get the second mark. And then 15, or the minute mark, I mean, 15. And then look down at your plus sign. And in my calculator, it's green. But you see the second mark, looks like little quotation marks above your plus sign? So you gotta press the green button. Well, for me it's green, I don't know what it is for you. And then that will pull up the seconds. So we get 78.1875. So where do we get the seconds? Not from the angle menu. We get the seconds above the plus sign.
Couldn't you just put the minute button in twice?
I don't know. Why don't you try and see?
I don't think so.
I don't think so either, but maybe. I've never thought of that or tried that. Okay, so now we know a little bit about how to put this stuff into our calculator, because that'll be important. Well, there's a few homework problems like that, but then we're going to need that as we go through for sure. Okay, so today our focus is on a couple of things. First of all, we've got to talk about a new way of measuring angles. Did you do radians last year? So you've never heard of a radian before? Okay, well, you know that if I told you to measure this room, you could do it in feet, you could do it in yards, you could do it in meters. There's lots of units of measurement you could use, right? The same is true of angles. Up to this point, apparently, the only angle measurement you've used is degrees, which is fine. But in upper mathematics, starting now, we're going to focus a lot on this other unit of angle measurement called the radian. Here is what a radian is. I'll give you the definition and then I'll show you. It's the measure of an angle determined by striking an arc of radius length. So that's the definition of 1 radian. Now, what does that mean? Well, here's my circle. Let's say that circle has a radius of 5. If I took a piece of string, 5 units long, radius length, 5 units long, and laid it around the circle, so that arc is 5 units long, the angle determined by the end points of that string would be 1 radian. So if I had a circle with a radius of 6, and I wanted an angle of 2 radians, how long would that piece of string have to be? Perfect. Now, you done with the thing?
I was with Mrs. Song.
Oh,
Yeah, I got in trouble.
okay. Did you have full shirt on?
I do not.
You have just discovered, we're going to spend more time on this in a minute, but while we're here, you've just discovered a really important relationship. The arc length the arc, the measure of the arc, is the product of the radius times the radians. Now, do not be confused by that for 1 second. You guys figured this out. You know that. The length of that arc was 6 times 2, right? Radius times radians. So, if I gave you a problem, or in the book, they gave you a problem and said, okay, you have a circle. The arc length is, oh, let's say 10. And the central angle is 1.5 radians. Could you find the radius of the circle? Absolutely. Arc length equals radius times radians. So 10 equals r times 1.5. So what does a radius equal? 10 divided by 1.5, which is?
6.6.
So 20 thirds?
Yeah.
That's pretty easy, isn't it? Here's an issue. See if you can tell me what the issue is. Let's suppose we have the same kind of scenario. Circle. And I know the radius is 6, and the central angle is 35 degrees. What's the arc length? Now, we have a bit of a problem, don't we? What's our problem? It's in degrees. And if we're calculating arc length, our angle has to be in radians. Now, you spend a lot of time, particularly in chemistry, switching from one unit to another. If you've got feet and you need inches, you know what to do, right? You times it by 12, and you've got it. Well, we have degrees and we need radians. So here's how we're going to make that change. It's very simple. Pi radians is 180 degrees. So half a revolution, a semicircle, is 180 degrees, and it's pi radians. Oh, look who's here! Yay! Find her a seat. So this is fact. This is like 12 inches in 1 foot, 3 feet in 1 yard. Pi radians is 180 degrees. So I know that pi is the same as 180. I want to know what's the same as 35. So I simply set up this proportion. Pi radians is 180 degrees, always. That will never change. How many radians then is 35 degrees? If pi is 180, how many are 35? Does that make sense to you? So then we'll just multiply. And 35 pi over 180, I will want to reduce that fraction. By the way, if you have a calculator available to you, you can reduce, you probably already know this, but in case you don't, you can reduce that fraction really easily. Just do 35 divided by 180, and then hit math, fractions already highlighted, enter twice, and it reduces it for you, 7 pi over 36. Don't put the pi in, just put the numbers in. So one more time, in case you didn't know how to do it. 35 divided by 180 equals math, this is your math button right there in the first column, and hit enter a couple times, and it will come up for you. Now, here is what happens every time. Kids will get so excited and they'll put this down in the answer blank. Remember, what was the original question? Find the length of this arc, right? What's that? Radians. That's just the central angle. That's this. That is not the answer to the question. So now, how am I going to get the answer to the question? Arc arc length equals radius times radians. 6 will cancel into there. I got 7 pi over 6. Did you? Now, I didn't give you a unit. If this had been 6 centimeters on the radius, if the radius had been 6 centimeters, then the arc length would be 7 pi over 6 centimeters. Whatever this unit is the same as this unit. All right? Well, let's have you change another one on your own. See if you can change it. Let's change 100 degrees into radians. And then let's see if you can change 8 pi over 5 radians into degrees. Give those a shot. Remember, this is the fraction you're going to start with every time. Pi radians, 180 degrees. Go ahead and fix 5 to 10 minutes while you're working on that. You all got the first one. Without issue. Did you say pi is to 180 as something is to 100? So x equals 100 pi over 180, 5 pi over 9.
Yeah.
Everybody okay with that? Now, did you do the same thing with this one? Could you? Let's think about it for a minute. We know pi is 180, right? Right? So we want to know how many degrees are 8 pi over 5 radians? Now let's not be freaked out about that. Let's cross multiply. Let's reduce that. I'll let my calculator do it. 8 times 180 divided by 5 is 288. So pi x equals 288 pi. So what does x equal? 288. Now, did anybody do that a different way? Because there actually is a different way to do this.
I knew that 8 pi, you could simplify that as pi over 5 equals x over 8. Just because when you cross multiply, the 8 goes to the top.
Okay.
And then to get 180, you multiply 5 by 36. So then multiply both sides by 36.
Okay. That'll absolutely work. I'm thinking of something that's even less complicated than that, though. It kind kind of along those lines though. Every pi radians is 180 degrees, right? So what she's saying is, okay, pi radians is 180 degrees. So what would pi over 5 be? Well, if pi is 180, a fifth of 180 is 36. So this is a fifth of pi, it's a fifth of 180, 36 times 8. That's kind of what you get. That'll work every time. So if you had 2 pi over 3, what's pi? 180. Divided by 3 would be 60 times 2 would be, yeah. So if you want to do it that way, you absolutely can. Okay? All right. Let me do a couple more problems, and then I'll give you a second to regroup, get ready for the quiz, and then we'll take the quiz. Look in your book, page 34, or no, page 356, number 34.
What page is it?
356. And it talks about concentric circles. That's like this. Circles within circles that have the same center. And it says we have a central angle theta. You saw that on your red sheet. That's a Greek letter. The Greeks are the ones that came up with all this trig stuff. So our variables are Greek variables, alpha, beta, gamma, theta. If you don't like it, make it X. Doesn't matter. Intersects arcs S sub 1 and S sub 2. So that angle makes that little arc, big arc. In number 34, we know that the little radius is 8 and the little arc is 36 and the big arc is 72. That's the given. Your job is to find the big radius. Now, I don't want you to be befuddled. I want you to look at this, try to get all the rest of this out. Look at just this little circle. We know that 36 equals 8 theta, right? Would everybody agree with that?
Yeah.
Well, how do I know that? Arc length equals radius times radians. So just looking at the little circle, arc is 36, radius is 8. So that angle must be 4.5 radians. Double check my arithmetic, is that right? Is that 9/2?
Yes.
So that angle is 4.5 radians. Now, isn't that the same angle for the big arc? So 72 equals, I don't know what the radius is, but I know the angle is 4.5. So the radius is 72 divided by 4.5, which is what? Now that we've done it, does that kind of make sense? Because why?
36 and 76.
This arc was twice this one. So doesn't it make sense that the radius would be twice? Since we're using the exact same angle. I mean, that's critical, using the same angle. But we went through all the steps, so I already got it. Bailey?
I thought you couldn't divide by
can't what now?
You couldn't divide by like an equal number. You had to do the change into radians. I thought you had to change the 12
To what?
radians.
It is radians, sweetie. When we solved it right here, when we said arc length equals radius times radians, that is a radian measure. It came out the first time we did it. We can divide by angles. I think what your question was, is it a degree or a radian? It's a radian already. Okay? All right, Robert?
If you see that 36 and 72 are like just divisible by 2, like if you know the answer is going to be doubled as well.
You do in that particular problem, yeah, with that scenario.
Okay.
Yeah. Okay, take a minute, get yourself organized, get ready to take our memorization quiz.
Mrs. Ford, did you also do something like this where you said it like
So it's the angles the same.
okay.